Hello guys, last week we discussed about the chain rule and I solved a few problems based on this rule, and some of you asked for a few harder problems, and today I'm going to solve a few harder problems based on this rule. As you remember, when we are dealing with a complicated function and we want to take the derivative of that function, and if the function has an outside function and inside function, we have to take the derivative of outside function and keep the inside as it is, and then multiply it with the derivative of inside function. Also, we discussed about the power rule, which says that when we have a variable like x to the power of n, we have to use the power as the coefficient and reduce the power by 1, as you can see here. So we have the derivative of x to the power of n, and then we'll get n times x n minus 1. So let's start the first examples. We have the root 5 of 1 minus 6x. So the best way for solving of this problem is to convert this from the root to a fractional exponent. So to do that, we write the function as 1 minus 6x to the power of 1 over 5. Basically 1 is coming from here and 5 is coming from here. So now we have basically a fractional power, and we have one inside function, as you can see here. So in order to take the derivative of that one, we have to use the chain rule, and this is going to be the inside function for us, and the power that we have is going to be the outside. So first we take the derivative of outside function. So we will have du over dx equals so the derivative of outside function is going to be 1 over 5, and we keep the inside as it is, 1 minus 6x to the power of 1 over 5 minus 1. And now it's time to take the derivative of inside function, which is 1 minus 6x. The derivative of a constant number is going to be 0. Derivative of a constant times the variable is going to be the constant number. So we'll get minus 6. So the answer at the end is going to be du over dx equals to minus 6 over 5, 1 minus 6x to the power of minus 4 over 5. So as you can see here, we easily applied the chain rule. First we looked how we can simplify the equation that we have, and then based on that simplification we started the use of the chain rule, and we take the derivative of outside function in the first step and then keep inside as it is, and we multiply it with the derivative of inside function, as you can see at the final answer. Now let's look at the next example. For this example, as you can see here, we have a constant number times a trigonometric function, and basically this sine function here is going to be the outside function for us, and the other thing that we have is x2 plus tan x, which is going to be the inside function for us. And the procedure is going to be the same because we have an inside function and outside function, so we have to use the chain. So we have to use the chain. So for using the chain rule, first we need to take the derivative of outside function. So for that one, in order to do that, basically we need to take the derivative of sine, which is going to be du over dx equals 5 cos x2, we keep the inside as it is, plus tan x. Now it's time to take the derivative of inside function, which is x2 plus tangent x, and this is going to be multiplication with 2x, and the derivative of tan x is basically secant plus secant squared x. So the final answer for here is going to be du over dx equals 5 times 2x plus secant squared x times cos x squared plus tangent x. So easily we got the answer for this problem with just using the chain rule and applying the inside and outside function rule basically. So let's look at the next problem. For here, what we have is 5x plus the exponential of x squared plus 7x. So as you can see here, for this term, we just need to use the chain rule. So for this term, we need to use the chain rule. And for this exponential function, basically e, this is going to be the outside function for us. And this is going to be the inside function. And for 5x, basically it is a constant number times x, so easily we need to take the derivative of the constant number times x, and it's going to be equals to the constant number. So the derivative of this function du over dx is going to be u prime equals 5 plus the derivative of outside function, which is going to be the same thing that we have, x2 plus 7x, and then the derivative of inside function times 2x plus 7, and this is going to be the answer for this problem. So with just using the chain rule and finding out which one is basically the outside function and which one is the inside function, we could easily find the derivative of several complicated functions. Let's look at the last example that we have for today. So we have the natural log of x squared plus sine x, and for this problem we have to see which one is going to be the outside function. Again, we can say the natural log is basically the outside function, this is the outside function for us, and the inside function is going to be x squared plus sine x. Inside function. And what we have to do again, take the derivative of outside first and keep the inside as it is and multiply it with the derivative of inside function. So for here, what we have is the derivative of natural log is going to be du over dx equals to u prime. So this is the form of representation. You can write it as du over dx, or you can write it as u prime equals to 1 over x2 plus sine x, and basically this is the derivative of outside function, because we know that the derivative of ln x is 1 over x, and here basically the x function is x2 plus sine x. And now it's time to take the derivative of inside function, which is 2x plus cosine x. So the final answer for this problem is going to be 2x plus cos x over x squared plus sine x. Hope you enjoyed watching this video. If you enjoyed and learned the chain rule and dealing with complicated derivatives, please subscribe our channel. Thank you very much.